Hi, everyone. I want to welcome you back to Math 103, and I'm glad to say that we're doing okay here. I hope that your families and all of you are doing fine where you are. I'm sorry we have to go through this to complete the course, but I guess we have to do what we have to do. So this is the first probably of two videos you're going to watch to help you prepare for a test which is called Virus Quiz 2. Crazy name, but it's a quiz that I put together to check out your knowledge of the stuff that I'm going to be going over in the next two videos. This one that I've started and the second one that I'm going to do also. We're going to go over two sheets called Group Work Virus number 1 and Group Work Virus number 2. And these sheets will get you ready and are what you need to study to be able to successfully complete the virus quiz number 2, which I'm going to ask you to complete by the end of this weekend coming, which is about April 4th, I would say, or April 5th. You're going to have to send the quiz to me either via your phone, take pictures of it with your phone, or you're going to have to scan it and email it to me at taxes@gkcapture.com, the same email address that I use to contact you with your emails. Now, before you begin looking at this video any further, I would like you to make sure that you have either printed Group Work Virus 1 and Group Work Virus 2 so that you can do the work as I do the work so that you will be able to perform well on the quiz that's coming up, which you will receive on Thursday. So in your email you just received today, along with these two videos, you should have with you the worksheets that you need to complete. The first part of this is going to be kind of review. Sorry about the clocks, but the first sheet that we're going to begin with is not, you do not have it. I'm just going to review the stuff about the different kinds of numbers we've been talking about over the last 2 or 3 weeks of class. And then we'll get into the actual sheets and work on them together. So this, first of all, is going to be a review to help you get ready for the stuff you need to know about the different kinds of numbers in our number system, which will be tested on this video quiz that you, or not video quiz, but virus quiz you're going to take over the weekend. Okay, so I'm going to share the screen now, and so that you can see what it is I am doing, as if we were working on the smart board. So let's see what we have here. All right. So we should have a shared screen up here now, and away we go. All right, the natural numbers. We've talked about them extensively since even the beginning of the course. And if you recall, the natural numbers are the numbers that you learn to count with, okay? If we write them using set notation, if you recall, it would look something like this. You would write 1, 2, 3, 4, 5, 6, 7, and we use the ... notation for people to realize that it goes on to infinity. And of course, without the braces, it's called a list, but with the braces, it's called set notation. So you are very much familiar with the natural numbers. Then we discussed the fact that when you got to school, you learned that there was another number you needed to be able to add, subtract, and multiply these whole numbers. And well, that made the set of whole numbers actually, and that number was 0. So when you add 0 to the set of counting numbers, you have the set which is referred to as the whole numbers. Okay, and of course we discussed this at length a couple of weeks ago. Then you looked outside the kitchen window and you realized that there were numbers below 0 on the temperature scale that you saw out there. So therefore you realized that there was another set of numbers with those minus signs in front of them. And of course, they're not called minus numbers. The numbers, when you put the whole numbers that have minus signs in front of them together with these numbers, you have what is called the set of integers. Now, we are used to, as a kid, writing the set of integers this way. You would come in from negative infinity go out towards positive infinity and use the dot, dot, dot notation. Well, and you know that I have suggested to you that we don't have to write the numbers this way. We actually can write these numbers using only one direction to infinity. So in other words, we could rewrite this set a little differently by writing it as 0, 1, -1, 2, -2, 3, -3, 4, -4, dot, dot, dot. And notice now we are heading to infinity only in one direction. You know that all the numbers that are integers would be there if we continued this process the way we started it, using the same pattern, 5, -5, 6, -6, and so forth. So both of these are decent and acceptable representations of the set of integers. Now, before you learned about the integers, you learned about those awful things called fractions. And fractions, of course, are defined in our number system by a different name. And as you recall, the name given to the fractions are, or is, the rational numbers. Now, I'm going to write out the definition again for the rational numbers. You already probably know what it is, but just in case you can't remember, I will write it out nice and slowly now here for you. A rational number is any number that can be expressed as the quotient of two integers in the form A over B, where B cannot be equal to 0. Now, you will recall, we have discussed this prior to what you're seeing now. You cannot divide by 0 in our number system. You know that. When you do it on a calculator, you get an undefined answer or an error. So division by 0 is totally impossible. That's why rational numbers cannot have zeros as denominators. Now, as you recall, with rational numbers, the Greeks felt that all numbers could be expressed as the quotient of two integers. And as we have discussed, they found out they were wrong, because you cannot write all numbers as the quotient of two integers that we can possibly think of. I'll come back to that in a moment. But if you recall, the rational numbers have two ways that they behave if you try to divide them out and convert them into decimals, okay? So let's take a look at that. Let's take the fraction 4 over 3, or we can make it 4 over -3. If you divide this out on your calculator, you find that you get 1.3333, and the 3's just keep on going forever. Of course, it should be a negative sign here. That is one thing that can happen when you try to convert a rational number or fraction into its decimal equivalent. That's called repetition. And if you recall, repetition can be shown the way I have it up there now, with the 3's and the 3 dots after them, or it can be expressed using what I call drinking notation or bar notation. And you recall this from middle school: when you put the bar over the 3, it means the 3's continue to repeat forever. So there is one example of one type of outcome you can have when you convert a rational number into its decimal equivalent. The other type of number you can get when you convert a rational number into its decimal equivalent, if you recall, is a decimal number that terminates. It stops, okay? So for example, if I use 2/5, let's say I use the fraction 4 2/5, that will give me a 4. If you divide 5 into 2, you will get 0.4, and it doesn't go anywhere else. It's just 0.4. If you divide 5 into 2, all right, it goes exactly 0.4 times, okay? So this decimal has what? It has terminated. So how I usually have you show that on a test is if I ask you on the test, which you know I'm going to, what is the decimal behavior that occurs when you take a rational number and convert it to a decimal? One of two things can happen. It is either going to repeat, so you can put down a capital R, or it is going to terminate, a capital T. I will accept those as answers, okay? So I have no problem with you showing me a capital R or a capital T. Now, we have begun to discuss how you change these decimals back into the fractions they came from. The only one I'm really concerned with you remembering for this test that's coming up is the following. I want you to be able to remember that when you have a repeating decimal, all right, I've got on the wrong page here, excuse me a minute. Let me erase all this. Okay, give me a second to do that. Okay, when you take a repeating decimal, as long as it's a chunk that you are trying to change back to the fraction it came from, for example, what if I use 7, excuse me, I better turn on the writing utility here. If I want to write 7.315 bar as the fraction it came from, remember you would keep the 7 because there are 3 digits repeating in the 315. You can use what I call the Kelly's cheater method to convert that back to the fraction it came from. So it would simply be 315 over 3 nines, okay? Now, I'm not requiring you to reduce that fraction, but if you take a calculator and you take the calculator and take 315 and divide it by 999, you will get on your calculator 0.315, 315, 315, 315 forever, okay? So we're going to also talk about ways to change these fractions back into, excuse me, these repeating decimals back into the fractions that they have come from, okay? So that is part of the material you're going to have to know for the upcoming test. Now, we then discussed that the rational numbers, which by the way can be whole, rational numbers can be integers, rational numbers can be natural numbers, all right? But they don't make up all the possible numbers we could have in our number system. And if you recall, we found another name for a given set of numbers which are not rational. And the first example we came up with was pi. If you take a look at pi, which of course is 3.1415927 to about 7 decimal places, pi does not repeat as a decimal. If it did repeat as a decimal, we could turn pi into a fraction, okay? And so therefore it would be rational because it would be the quotient of 2 integers. Pi does not have that characteristic. Neither does phi. Phi, of course, we have been discussing it in class also, 1.618034. It continues on forever, all over the place, okay? It's not a repeating number at all. And since it goes on forever like this, just like pi does, it is referred to as an irrational number. Remember, irrational numbers mean not rational. Ir means not. Rational is a quotient of two integers, but an irrational number is one that doesn't have that characteristic. Okay? Your typical radicals that you're used to seeing, radical 2, radical 3, radical 11, the ones that, quote, don't come out even, are also examples of irrational numbers. Okay? All right. Now, hopefully you have remembered this from the discussions we have been having in class, but I did want to briefly go over it with you just to make sure you're aware of it, because this information will be tested on this test you're going to take called Virus Quiz number 2. Okay. Now, when you put together the irrational numbers and the rational numbers, remember the rational numbers can include the whole numbers, the integers, the natural numbers, okay? When you put all these numbers together, you have the set which is called the real numbers. So we're not going to deal with imaginary numbers at all in this class. So we're going to say that the largest set of numbers, it's obviously infinite, that we are going to deal with is the real numbers. They are made up of rationals and they are made up of irrationals. Now, hopefully, this short review has been helpful for you to be able to help you continue with what we're going to discuss today for reviewing for the Virus Quiz number 2, which you're going to take over the weekend. I would just like to go back here for a moment and take a look at this term right here, dot, dot, dot notation. You recall that if we want to show something is continuing in the same pattern, we can use this dot, dot, dot notation. For example, if I want to show that I have a decimal that is repeating 4 5s, I can put 3 dots after it to show that that continues in the same pattern. Okay? All right? That pattern is what we call repetition, and we can use it for 0.45 bar here. All right? Now, there are other numbers that you can have that show patterns, but the patterns are not repetition. The patterns actually have an irrational behavior to them. Let me give you an example of that. I can have 0.45, 4 5 5, 4 followed by 3 5s, 4 followed by 4 5s, and if I put 3 dots after that, what that means to the reader is that this number continues to infinity, but the number of 5s continues to increase using the same pattern. First there was 1, then there were 2, then there were 3, then there were 4. So next there will be 5, then there will be 6, and so forth. This type of number right here, I'm going to call it the number A. A is irrational. It is irrational behavior for a number to show that kind of a growing pattern. The number above it is a rational number. I'm going to call it B. B is rational. The reason B is rational is I could convert that back to a fraction which it came from. Irrational numbers cannot be converted back to fractions because they didn't come from fractions. Therefore, they have irrational behavior. So I want you to get used to the idea that rational behavior shows repetition that's exactly identical in each step, whereas irrational behavior, if the number shows a growing pattern, then the number shows irrational behavior. Okay, so with those things in mind that we have discussed tonight, okay, I would like to work on the first sheet, which is called Group Work Virus 1. So if you would put group work virus 1 in front of you, it should look like this. Okay, the first thing you're going to have to be able to do on this quiz that you're going to see is to be able to determine a rational number that exists between those two numbers right there. Now you'll notice 0.002357 and 0.002358, okay? They are rational numbers. I would like you to find a rational number that's between them. The simplest thing to do to find a rational number between them would be to add them together, as you recall, and divide them by 2. The answer you obtain will be rational and it will be between them. Now, if you take out your phone or a calculator and you put those two numbers in it, this is what you would obtain for an answer. 0.002357. It would terminate, it would stop. Now, because it stops or terminates, we know that this is what kind of number? Well, it's rational, because rational numbers as decimals either terminate or repeat. This one that you see on the screen has terminated. Could I have made that number repeat? I could have. I could have put a bar over the 5 and told the 5 to keep repeating forever to infinity. That number also is a correct answer for a rational number that is between those two, okay? So you could either put an answer which is a repeater or an answer which terminates just as long as it's between the two numbers that have been given. Remember, the simplest way to get those two numbers, or to get that number between them, is to take the two original numbers, divide them by 2, and write the answer down, okay? Now I want you to look at number 2. If you take your calculator and add those two numbers together, I'll give you a couple seconds to try it, and you divide them by 2, you should obtain 0.048155. Now, that number has stopped. It is not going on your calculator, right? However, we want an irrational number that's between these two numbers, not a rational one. Let me get my picture out of the way up here, okay? So we want a number that's irrational that's between those. Well, there are 3 answers that I would accept. Well, there's a ton of answers I'd accept, but there are 3 number answers that I can show you examples of here, which would be irrational numbers between them. One thing I could do is just put a whole bunch of numbers down after them, after the 5, 5, just so that they're all over the place. And then I could put 3 dots. Now, you don't see any pattern in any of those numbers. You don't see any repetition in any of those numbers. So you could assume that this is a number that goes on to infinity. It never stops, goes on to infinity, but it also never repeats. Therefore, that is an irrational number. So that is one answer that would be acceptable to giving us an irrational number that's between those two numbers. Okay? All right. Now, let me erase what I put on there and go back to the original 5, 5 I got when I divided them. Okay? Another way that I could show that I have an irrational number that's between these would be for me to draw an arrow after it. Whoop, I forgot and left on my eraser here. Let me put the 5, 5 back. If you put an arrow on there, that's a Kellyism, remember. I will count that right. You are telling me by putting that arrow that this number goes on forever and it's all over the place. It's not going to repeat, and it's certainly not going to terminate. So I would accept that answer as an answer for an irrational number that's between these two. The third way, and my favorite way to show this answer as an irrational number between them, is to do this. It's to put a pattern on this number. When you put the pattern on this number, it would go something like this. You could do any pattern you want, but I'm going to use a 1, then I'm going to put 5, 5, 5, then I'm going to put another 1 and 3 5s, 4 5s. Now I've established the pattern. See the 1 and 2 5s, then the 1 and 3 5s, then the 1 and 4 5s. If I put 3 dots after this, it tells me that this continues to infinity, and it also tells me the 5s keep growing. That is an irrational pattern and is a correct answer for question number 2. Okay, let's go on. Let's go to question 3. Convert each of the following fractions into their decimal equivalents. You may either use ... notation to do this, or bar notation where necessary. You can use your phone or a calculator to do this, okay? So what I'm going to do is I'm going to bring up the calculator here on this machine, okay? And I'm going to divide these out for you very quickly and show you how we can write the answers. Hopefully it's going to work out. Let's see if the calculator will come up. Okay. Now I believe the first example was, I got to do that over here this way. Okay, I'm going to take 5. Let me clear this out. I'm going to take 5 and divide it by 18 on this calculator. And you'll notice the answer I get is all repeating 7s after the 2, and the 8 on the end, I think you are aware, would be rounded off on this calculator. So we're not going to use that, okay? So we're going to have to realize that this is repeating 7s, okay? So therefore, the answer we would write, okay, for 5 divided by 18 is 0.27 with a bar over the 7. So 0.27, and I can put a bar over the 7 to show the repetition, all right? Or I could do 0.27777 ... It's the same thing as showing what I showed with the bar notation. Okay, now to give myself more room, I'm going to erase the second answer here. How about 5/12? Okay, so if I bring the calculator back up, okay, I can take 5 and divide it by 12. And when I do that, you will see that I obtain 0.416, and then the 6s start repeating, okay? So the answer that is acceptable for the question we just had is to write 0.416 with a bar over the 6. Incidentally, you can't use the Kelly's cheater method to turn that back into the fraction it came from, because it's not a whole repeating chunk. Same thing is true with the letter A up there. I can't use that cheater method to convert that back to 5/18. I just want you to be aware of that. Okay, let's go to C. I can put the whole number down, 9 point. And now what I'm going to do is I'm on my calculator. I am going to divide 3. Let me clear it here. All right. Divided by 22. And when I do that, you can see I get 1 and then 3, 6, 3, 6, 3, 6, 3, 6. So It is 9.1, and then I have the 3 6s are repeating. Notice that that bar should not be over that 1. So let me erase that to make sure you don't get confused by that. The bar is only over the 3 and the 6. Now, if you recall, when you convert the sevenths, and we discussed this in class, the sevenths are 6-digit repeaters. So it's going to be very hard for you to see this on the calculator I have here. But if I divide 1, let me hit clear here, 1 divided by 7, enter. Notice it's 142,857, and then it goes 143. The 3 is actually a 2 on the calculator, but this repeats in a group of 7. So it is 142,857. So this would be -4.142857 with a bar over the entire thing, because those 6 digits go on and repeat. Okay, so there's a quick review of dividing fractions out to convert them into decimals. I probably won't even put any of those on the quiz, but I will put ones like number 4 on here. You can use the Kelly's cheater method to convert these back to the fractions they came from. It is really simple, gang. All you got to do is what? Look at how many numbers are repeating, put the whole number out there, and you don't need the decimal point, so I probably should erase that. Okay, so let me put the 5 back down again properly. So it's 5 point. No, I don't need the point. I keep putting it down, but I don't need it. So let me erase it again. I just want the fraction. The fraction is simply, okay, 5 and 72 over 99. Now, you can reduce 72 over 99. It reduces to 8/11ths. And if you take your calculator and divide 8 by 11, okay, you will obtain 0.72 bar, okay? I'll let the clocks ring. It's 10 o'clock here in Western New York while I'm making this video up for you. So I got to wait for them to quit ringing. Now, letter F, you would put the 7 down, and you would put the 315 down over how many 9s? Well, it's 3. 4, letter G, it would be -2 for your whole number part, and you will put 495 over how many 9s? As it turns out, it'll be 4, because this repeats as 0.0495, and again, 0495, 0495, 0495. This answer divided out will give you that repeating decimal. And finally, let's do 3.87 bar. It'll simply be 3 and 87/99. Okay, so there we go. We've got the problems 3 and 4 done. Okay, now you'll recall we did a lot with clock arithmetic or modular arithmetic, and you're going to have to know on the test how to convert or determine the missing letter X in this bank routing number, okay? To do it, you have to use your modular arithmetic knowledge for Mod 10. By the way, there will be no credit cards on this test, and there will be no credit card on the exam. I'm only going to have you deal with bank routing numbers or with UPC codes. No credit cards, so you don't have to worry about those. Now, I will always tell you on the quiz or test or final exam that the code you have to multiply by, this bank routing number by, is 739 739, 739. Okay? Now, with that in mind, let's put the 739 under here. And let's multiply all the numbers together. All right, we'll get the answers first. Then we'll convert any of the numbers we get into mod 10 numbers. So this is 7x, 27, I usually underline a two-digit number, 45, 21, 21 again, 36, 56, 18, and 0. Now, all the numbers I underlined, I'm going to change to mod 10 numbers. And if you recall, any number in mod 10 arithmetic is the last digit of the number you're looking at. So 27 is simply 7, 45 is 5, 21 is 1, 36 is 6, 56 is 6, and 18 is 8. Now, if you recall, the requirement of any bank routing number is that when you add all its digits together after you've multiplied by 739, 739, 739, and so forth, has to come out 0 mod 10. So we write this equation, 7x, the number we're missing is x, increased by what number has to come out 0 mod 10. All right, I'm going to add the numbers in both directions. Hopefully I'll get the same answer. So 7 and 5 is 12, 13, 14, 20, 26, 34 I got. I'm going to go the other way now and see if I get 34. So 8 and 6 is 14, 20, 21, 22, and 5 is 27, and 7 is 34. Now I have to ask myself, what does 7x, if I multiply 7 times whatever my value of x is, x has to be a one-digit number, what number times 7 will end in what I need to make 34 end in a 0? Well, I think you can see for 34 to end in 0, whatever you multiply 7x to be, or when you multiply it out, it has to end in a 6, because 34 and 6 would be 40, which would be 0 mod 10. So if I have to have 7x end in a 6, what number times 7 ends in a 6? Well, 7 goes into 56 8 times, right? So 56 is the number I need to add to 34, because if x is 8, 7 times 8 would be 56, and 56 added to 34 would be 90, which is 0 mod 10. So therefore, I have correctly figured this answer out. The value x must be in this bank routing number is x equals 8. All right, moving on to the next problem. It says, write the definition of a rational number. I'm going to give you a couple seconds to see if you can write that out. And then I'm going to state it for you again. What you should have written is this. It's any number that can be expressed as the quotient of two integers in the form a over b, where b cannot equal 0. Now, if we go back, I have that written right there. Unfortunately, you probably can't read it. But any number that can be expressed as the quotient of two integers in the form of a over b, b cannot be equal to 0. You know I'm going to ask you this on the quiz, right? So make sure you remember this so you will do well on the quiz. Okay. It says to clearly describe in problem 7 the decimal behavior of an irrational number. Well, if you recall, I'm sorry, I skipped 7. Let's go back to 7. Clearly describe the decimal behavior of a rational number. Well, you can simply write this down. It repeats or it terminates as a decimal. R or T. I'll accept that. That is absolutely correct. So it'll either repeat or it will terminate. 8 says clearly describe the decimal behavior of an irrational number. Okay, so to answer this, you should say the following. It goes on forever. Never repeats or terminates. But if you just say never repeats, that's probably enough, okay? All right, now, please remember that an irrational number can show a pattern. Remember, like 0.26, 266, 2 followed by 3 sixes, 2 followed by 4 sixes to infinity, right? So remember that, okay? It may show a pattern, it does not have to, okay? So you need to know the answers to these two for sure when you take this quiz this weekend, okay? All right, now we're going to take some time to practice a couple problems where I'm asking you to convert them to a different modular system. They're not mod 10s, they're a different modular system, okay? So let's try number 9. First thing we have to do is 8 to the third power, all right? And I believe 8 to the third power is 512. 13 times 5, that is 65, okay? And to do this conversion, what I need to do is add those two together. The answer should be 577. Now I need to convert 577 to a mod 5 number. And if you recall, all you have to do to convert that to a mod 5 number is to divide it by your mod number. Now, I'm going to do it longhand here. Goes once again, and 5 times. You'll notice I have a remainder of 2. Remember, the remainder is your answer. So this number, written as a mod 5 number, 577, when you divide it by 5, it produces a remainder of 2, okay? Since 2 is the remainder, it is the answer. So this answer should be 2 mod 5, not 3 mod 5. So this answer is false. Now remember, I said that you can do this on your calculator, okay? So if you take and work the problem out and use your calculator to do the problem, you could take your 577 here, 577, and divide it by your mod number, 5. Notice you get the whole number, 115. Throw away your decimal. If you simply take the 115 part of it and multiply it by your mod number, 5, you get 575. And if you notice, if I go back to my problem I got a remainder of 2. What would you get if you subtracted 575 from 577? You would get a remainder of 2. Therefore, I have done this problem correctly. So when you do the test, you may either use a calculator or you can divide them out longhand. Either way. Okay, let's tackle letter B. All right, so I'm going to first on my calculator multiply 8 times 17. So over here, I'm going to do 8 times 17. I got 136. So I'm going to put 136 down here. I'm now going to do 21 times 40 on the calculator. So I will do 21 times 40. And I got 840, okay? So I go back. So this is 840. Now what I need to do is add these two numbers together and then divide by what mod number? I need to divide by 8, correct? Because I want to change it to a mod 8 number. So when I add these together, I believe I get 976. All right? So I'm going to use the calculator to do this. I'm going to take 976 and I'm going to divide it by 8. So I take 976, I divide it by 8, and I obtain 122. Whoa, look at that. It came out even. Now, if it comes out even, what's that telling me? There's no remainder, right? So since there's no remainder, the answer for this problem would be what? It would be 0, okay? So all I have to do is write down, this came out exactly 122. There is no remainder. It is 0, so this should be 0 mod 8. So this is also false. When you take these types of problems and do them on the quiz, you must show your work like this and show me what it is you get for the answer and why the answer is true or false. Okay, what I'm going to do at this point is end this video, all right? So this video will stop at this point and we'll finish up. The second video will finish the first or the second page of this virus group worksheet, 1, and we'll also do the second group worksheet. So you can log in now to the second video. So do that at this time. So let me stop this. I'm going to stop the share and I'm going to end the meeting. I got to stop recording here somehow. I want to stop the video. Okay, and close it out.